between humanities and the STEM when I was younger, but when push came to shove, since I liked them both equally and one was obviously a little bit easier to make a living in.
That is Paul Prescod, a performance engineer over at Salesforce.org. I'm Josh Burke, your host for the Salesforce Developer Podcast, and here on the podcast, you'll hear stories and insights from developers for developers. Today, we sit down and talk with Paul about his project Snowfakery, which is capable of creating complicated and unique data records for testing. But we start, as usual, with his early years and an interesting origin story of an Apple computer.
So my dad was more or less an electrical engineer. He didn't have a degree in that. He was an electrician, but he actually built an Apple II computer, a clone.
Really?
He was in this strange situation where he had worked for someone whose job was to localize the Apple II to Europe, and then they had extra chips left over, and they said you could just go and build your own if you want. So he spent months in the basement soldering together. So it's probably the world's only wood-paneled Apple II computer.
I mean, considering you're talking about Apple hardware, which is extremely proprietary, I would think that that's probably highly accurate.
Yeah.
Nice. And I noticed on LinkedIn, you list games among the things that you have programmed. What kind of games are we talking about here?
Yeah, those were actually games to motivate healthy behavior. Through a long, strange path of career shifts over time, I ended up as co-founder of a company that made games, mostly mobile games, which motivated behavior change. So sort of, you could think of it as gamification, but also education and habit tracking all mixed together. So that was kind of what got me into the universe of software for good, software that makes the world a better place.
Nice. Now, can you give me a specific example of a kind of behavior that's getting changed there?
Yeah. So often just taking medication, there's all sorts of bad habits people have where they have some condition and then they feel like, oh, I feel better now, so I'll stop taking the medication that allowed me to feel better. And so we would, as I said, mix together education, explain to them why that's a bad habit, with gamification and habit tracking to, did you actually take your medication? And we got really deep into the behavioral psychology. We had lots of conversations with people like Dan Ariely and other experts in behavioral psychology. So that was an extremely interesting part of my career.
That is fascinating. And you kind of said the start of your interest in Salesforce, or I'm sorry, I jumped the gun there, software for good. And so then what, because I almost feel like there's an arc there, what led you into a role at Salesforce.org then?
Yeah. So I had sold my portion of that company and I took some time off to be with my kids, did some homeschooling and we did some traveling and that was all great. And I said, I don't want to move backwards. Now that I've discovered that it's possible to find a job where you can make the world a better place at the same time that you're, getting paid well and having fun, I'd like to do that again. And so I had a friend actually at church of all places that said, do you want to come work for Salesforce? And I was like, I don't really know much about Salesforce, but it seems, like a relatively typical big company from what little I know about it. And she said, no, actually, it's a pretty special company. She talked about some of the amazing philanthropic things that Salesforce in general does. And she said, and I work in particular for Salesforce.org, which is focused on nonprofits and educational institutions and philanthropy. So I said, oh, wow, that actually sounds like just what I'm looking for.
Nice.
But I was still a little bit leery because I didn't, so many people that come to work at Salesforce already have a deep understanding of the ecosystem. They already know Apex and all that sort of thing. But because the Salesforce.org, a lot of what they do is open source, I was just poking around at my friend's GitHub, and I stumbled across this thing called Cumulus CI, which is written in Python, which is my favorite programming language, and it's open source. And there was a job opening, so it was like the stars aligned. It was my dream job.
That is awesome. Okay, so today we're going to talk about Snowfakery, but before we even get into what Snowfakery is, I kind of feel like tools like this one have some kind of origin story, which is like a tipping point where a developer was like, darn it, I'm just going to build a tool to fix this situation. Is that kind of what happened? Like, what was the impetus towards building something like this?
Yeah. So that is pretty much what happened. So I was hired to be a performance engineer and in particular a tools builder, a performance tools builder at Salesforce.org.
Mm-hmm.
And you've interviewed my boss, Jason Lance, and you know that he and his at the time boss, Kevin Wilmer, they're very big on open source, and they're big on thinking how we can build things that are helpful to us, but also helpful to our customers at the same time.
Yeah.
So Kevin and Jason, before I arrived, already had this vision that we should be able to test our packages, and then customers should be able to test our packages on their computers, on their orgs, and then they should also be able to test their customizations of our packages so that they could determine whether a performance issue they saw was in our package or in their customizations, which is more often the case, to be honest. And so we had this vision of some sort of a performance engineering platform, and I thought let's work through this methodically. What is the first thing you need to do? Well, you need to seed the org with data that matches your schema. So I will put my focus on that. I did a little bit of everything else you need. A little bit of visualization, a little bit of automation of actually running the jobs, and so we have a full suite for all of those things. But once I got into the first part of the problem of data seeding, I was surprised that there wasn't really anything out there in the world. And I started doing it mostly as like a Python library that Python programmers could use. But we have these things in Salesforce.org called open source sprints, where we actually meet with our community and work with our community. So customers and system integrators and consultants and so forth. And we bounce around ideas and we collaborate. And someone at one of those, a friend of mine now, Aaron Crossman, said, what if we could build like a declarative, that you wouldn't even need to be even a Python programmer, even lower the barrier. And I wasn't actually at that sprint, so he collaborated with my colleague David Reed on a very, very early prototype, of what that might kind of look like. Yeah. And David Reed brought the idea back to me. And at first I was skeptical that the complexity of the data shapes. Yeah. So I almost started it to prove that it couldn't be done. And that we would have to fall back to Python, but I figured out some tricks and then some more tricks, and then wow, this actually is possible. And so I took that idea and I ran with it.
Nice. Okay, so let's dig into that a little bit more, because I think when people think, especially when if you look at blog posts and presentations and stuff like that, a lot of the representation of data that's going to be moved and created for test data is actually relatively simplistic. It's like, here's a few accounts we're going to show you, here's a few contacts we're going to show you. Like, how complex is that data shape getting and why?
Yeah. So it really depends on the domain. So that's the first thing, of course. Some domains do have extremely complicated data models, many layers of interrelated objects, and often they need to be synchronized in their actual data, so that the dates, at one level influence 3 levels down, or even a date influences, for example, an opportunity stage name. If the close date is in the past, then maybe the stage name should be closed, and those sorts of things.
Gotcha.
And so it's an interesting kind of almost philosophical question, which is you have to estimate to a certain extent the risk you have if your data is not representative when you're doing your performance testing. Right. So you have to have a mental model, I guess, of the code that you're working on and try to determine what level of data fidelity is actually needed. And it really depends on the complexity of your code, I guess, what level is needed. But the data models themselves can often be objectively complex, as you know, if you've been in this space for a long time. Right. And the subjective part is just all of the little details around business rules and accuracy of names and dates and those sorts of things.
Yeah. So there's the shape of it. And interestingly, the episode that's currently in the pipe, and I think if all things go to plan, will come out the week before this one. So if anybody's listening to this, rewind a week. And I'm talking with Karishma about like how important it is if you think that you're going to try to scale something, your architecture wise, like the litmus test is that you are testing against data that looks a lot like your production data, both in shape and also in scale. And it sounds like Snowfakery does some really interesting stuff when it comes to scale. But first, I do actually want to ask, why the name Snowfakery?
Yeah, so the idea is that every data record is like a snowflake. It's unique. It's created on the spot and unique and randomized, and it's fake data. So it's like a factory for fake snowflakes.
Nice. Was there a intentional naming tie-in between snowflakes and cumulus? or did that just sort of happen?
It actually mostly just sort of happened, but it is a nice coincidence. And at some point, we will also have a plugin to connect Snowfakery to Snowflake, and it will all the confusion will be completely completely circular.
I like it. And you can put it up on Azure, and then everything's just all lost. So I think you've touched on a few of these bits. So this might be kind of a summary question, but there are other tools that do these kind of things out there. I think I've even had at least one or two of them on the show. What was the thing that's like, you were like, no, I need Snowfakery to be able to do this in order to be successful for this goal? Yeah.
So there's a few different aspects. So the first is that we wanted it to be as declarative as possible, low code. We're not quite to the point of clicks not code, but we're low code. So that was the first main goal. Second, it did need to scale up to hundreds of millions of records, because Salesforce.org, we work with some of the biggest nonprofits in the world, and they have recurring donations. Some of them, you can imagine, have people who have been donating to them once a month for 10, 20 years. And, there's records for all of that stuff. So the scale can get enormous over time. So that was another one. Capacity to be integrated into Cumulus CI was another one. So Snowfakery is implemented in Python, the same language as Cumulus CI. Capacity to build these complex data shapes. The references, there were so many tools that would let you build any one table, but connecting the tables to each other, especially in a way that's compatible with Salesforce. I'm talking about tools that are not necessarily designed specifically for Salesforce. That was another gap that we kept running into. And we found a lot of people were using Makaru, which is, again, one of these mostly one table at a time type things. And then they were doing just unreal complex spreadsheets to build the relationships. And it was a very manual process. And every time you wanted to change the data, you basically had to do it again from scratch. So.
Gotcha. So, let's talk about that scale a little bit, because the general flow for Snowfakery seems to be set up that data shape, as you're saying, in YAML, and describe what it is that you're going to want, and then run Snowfakery either within the tool it's being associated with or on the command line. And then you output whatever it is that I can, then upload or insert into Salesforce or the database I'm working in. But what is there is a line in that YAML that is count, which is give me this number of records to be represented. What is the top number? What's the maximum value for that?
Yeah, that's a great question, and one that I get a lot. Just how much does this thing scale? And let me just first say that as cool as the count feature is, I actually encourage people to do the big numbers in the command line or in Cumulus CI. So what you can do is tell it to do a multiplication beyond that count. So you might have in your count, you might say, I want 20 records. And then on the command line, you could say that actually I want 100,000 or a million or 10 million. And it will just execute the recipe over and over again until it hits that number.
Is that just to ping on that a little bit? So is that kind of going back to the YAML that's describing the shape, but then the process is the one that's actually in charge of, I need 100,000 of that?
Exactly. And then you don't have to edit your YAML when you want to, you can, all the time I might be I'm just testing this. So I'll just run it on a small number of records. Okay, it looks good. Now I'm running it on, 100,000, a million, 10 million. It also has its own kind of a batch mechanism, which means that it can discard information it doesn't need anymore. So that makes it essentially unlimited in its scale. I can tell it I want 1 billion records, and it will only keep around, let's say, a couple 100,000 at a time. So it basically scales all the way up, and it's the org itself that has the memory of the first 990,000 records.
Gotcha. So Snowfakery itself is generally just not the limiting factor. It's whatever, it sounds like it's on the other end of the process. It's where you're trying to actually put the books on the shelves.
Yeah, exactly. Yeah. There are limits to every relational database and so forth, but Snowfakery itself discards information. So the limit is always on the other side.
Well, and this is a broad question. I'm going to just admit that, but just kind of on that point, what kind of tips and tricks in Python were you learning along the way to make that efficient?
Yeah. Well, that's a great question. I think it was more of a design philosophy than anything particularly that I learned, but it was really about that design philosophy of I'll keep around as little data as possible and upload it as quickly as possible, and then I can forget it. So it's a little bit, like using a notebook. You know what I mean? Instead of trying to just sit in a class and memorize everything, you use a notebook, and now I don't have to think about that. I can come back and review it later. So that I think is and the other interesting aspect about that is that I call horizontal striping, which means that I'm uploading, let's say, 10,000 accounts, 20,000 contacts, and 30,000 opportunities all at once. And then I come back and do 10,000 more, 20,000 more, 30,000 more. They're like packages or portions, since we use food metaphors often in Snowfakery because we call our scripts recipes. So so it's like a portion of food. So that's one of the things it also does that's different than a lot of tools. And so that again allows us to, once we've uploaded a particular portion, we can just forget about it altogether and move on.
So let's touch on that last part a little bit. So configuration files for your data shape, process for what that shape is going to be done with, but what kind of outputs/outcomes is Snowfakery capable of?
Oh yeah. So Snowfakery, in terms of data shape, it can represent every data shape that we've so far discovered. It can, join tables with no problem. Any kinds of lookup relationships and so forth are no problem. So I think a problem we have not yet run into, I think it might have a gap around polymorphic lookups, but no one has yet asked me to do a polymorphic lookup. So far that's theoretical, but I may have to add that feature at some point. I just realized that recently that I probably do have a gap around polymorphic lookups, but
nice.
I'll do that. And then sorry, just to finish up on formats, Snowfakery, it can connect directly to Salesforce orgs through Cumulus CI. So the output goes directly into the org. You don't have to do any extra load process. It also can output a CSV file, a JSON file, and the way of making new output formats is very straightforward. And so theoretically, it can connect to anything. And it does also connect to relational databases through SQL connection as well. So it can output to it can connect to a live relational database, or it could generate an SQL file.
Got it. No, I was just going to say, who doesn't have a blind spot when it comes to polymorphic fields? So.
And I forgot one other output that's a little bit fun is for reasonably sized data graphs, you can even output an image, a picture of the graph, which I use quite heavily in the Snowfakery documentation to say, with this YAML file, you'll get a data shape that looks like this. With this YAML file, you'll get a data shape that looks like that.
So as soon as you said that, I was like, why? But then as I'm saying, that actually makes, so that you can get a preview of what's going to happen before you throw anything into an org.
Exactly.
And also, that's
so
really,
that's
really
another
cool.
good reason why you don't want to overuse that count button. If you put a count colon a billion, then when you try to visualize it, you're going to have a problem.
Yeah. And I would assume if you accidentally press the command line on a billion count number, you're probably also going to have to go make yourself lunch.
Yeah, exactly. Yeah.
So, okay, so I do want to get into one of the cool tricks that it does. And I know other test factories do similar things to this, but I just kind of want to get a concept of the breadth of it, because you're creating unique snowflakes. What kind of, I guess, masks might be the right word, or because you can just say, I want my first name field to look like a first name. Like, how many of those sort of nouns is Snowfakery capable of faking?
Oh yeah, just tons and tons. So it builds on a library called Faker, Python library called Faker, and we've in Snowfakery 2, which is just coming up later, probably before this podcast launches.
Nice.
It's forward-looking statements, et cetera, et cetera.
Right.
It's all open source, so you can track the progress on our GitHub. But in Snowfakery 2, we have a quite elaborate documentation for what we've imported from Faker, and we contribute back to Faker as well as an open source library. But yeah, it's got names across just tons and tons of locales, Swedish names, Japanese names, French Quebec names. So yeah, it's got quite broad locale. And yeah, in terms of nouns, everything from IP addresses, banking numbers, credit card numbers, everything you would think of with respect to addresses, all sorts of computing things, different computing data types and so forth. Yeah, it's very broad, and you can build your own in Python. You can build your own with what we call a Python plugin. Or you can use a formula language. Snowfakery itself has a built-in formula language, so you could, similar to how you might combine two things in an Excel spreadsheet or a Salesforce org from two different fields. You can do that in Snowfakery as well, and you can do math in those formulas too, and you can do things like incrementing numbers as a way of getting uniqueness.
Nice. So back when you were talking about like some of the weird complexities, I mean, first of all, it's fascinating that somebody was like, I need only Japanese names. Here's a bunch of Japanese names for you. Could you theoretically, like, for instance, insist on first name and last name being Japanese names because the region field, for instance, is Japan?
Absolutely. Yeah.
Okay.
Yeah. In fact, there is a concept of a locale built into Snowfakery, so that you can say that this whole contact should be, and you can randomize that as well. You say that I want, a random mix of Japanese and Canadian and Dutch contacts, and then it will have all of the fields be in the correct locale.
Got it. And when you're setting up all those configurations, if you need relationships like that, do they need to be in the same YAML file, or is one YAML file capable of like pointing to other ones so that you can kind of divide and conquer your data shape?
Yeah, you can absolutely break up the YAML files and include other files. And we're working with the open source community that I mentioned before. We're trying to push the boundaries of making libraries of kind of reusable recipes that you can combine in the same way that you combine programs in a programming language.
Okay. So I'm now trying to get my head around that complexity times however many records I'm trying to put into a system, times the fact that Snowfakery is trying to be as efficient as possible and using as little memory as possible, I guess is a way to put it.
Mm-hmm.
And how are all of these records unique?
Yeah.
Help me get my mind around this, Paul.
Yeah. So at sufficient scale, if you need them to be literally unique, then you can do tricks like indexes, or UUIDs is something that's one of our built-in data types.
Got it.
I have an open issue that a colleague has given me a challenge of, like, can we get a UUID down to like 10 digits? And so I've got some interesting ideas about that. For now, you need, long UUIDs because that's just what's built in. But I think I have an idea for an algorithm that you could get uniquifying codes down to 10 or 12 digits and so forth. But yeah, without that sort of a thing, it's mathematically impossible. If you just have, standard first names and standard last names, eventually you're going to have a conflict, even if you no matter how inefficient your code is, because there are only so many unique first names and last names,
Right.
I know for a fact that there does exist another Paul Prescod in the world, and there probably is a different Joshua Burke and so forth.
There is indeed a different Joshua Burke with the last name spelling BIRK, which statistically, and I'm not even making this up. I actually have figured this out by doing the kind of weird name math that what you're kind of talking about here. BIRK is the 5th least frequent way to spell my last name.
Oh, yeah.
And that dude is in computers.
Oh, wow.
It's a little freaky. Like, if you Google, I have a bigger footprint, but every now and then people are like, I thought you weren't living in Bloomington anymore. That was the other thing. He's also, I think, a Midwesterner. We've probably met at some point. I don't know.
Yeah.
And I love the .org culture that's like, Paul, you're doing some really cool mad science, but could you do it a little bit more crazy and just get this down to 10?
Yep. That's definitely our culture. Yeah.
and speaking of this, I just have to ask, like, why is .org so in love with Python?
Well, I think it all started with Jason, and then he hired a bunch of us. So I think, it's one of those path dependence things, to be honest.
Yeah, it has a Jason Lance evil plan feel to it for sure.
Yeah, but it is a very, I mean, for the kinds of things we do, it is a pretty logical language. It's very fast to write code in. It's the types of actually, with the exception of Snowfakery, usually the types of things we do not need the highest performance. But Snowfakery does have to push the boundaries of Python's performance. But luckily.
Gotcha.
There's so much happening in the Salesforce org itself, and Snowfakery 2 is going to be multi-processor. So between those two things, we can easily generate data faster than the org can ingest it. Because a lot happens in the Salesforce org when it's doing data ingesting,
right.
all of the validations and triggers and et cetera, et cetera, et cetera. So yeah, we can pretty easily exceed the ingesting performance of a Salesforce org.
Got it. And I do want to talk about 2.0, but also just to wrap that up a little bit, the other thing I had noted whenever like Jason's showing me neat tricks that Cumulus can do, and then in my conversation with Pekka Clark about the robot framework, is how Python's insistence on nice formatting is so useful for tools like this, because even somebody who doesn't know Python can read a script and kind of understand what's going on.
Absolutely. We have so many Apex developers who work inside and outside of .org who say, I'll just learn enough Python to extend this thing. It may not be the most idiomatic code, but it gets the job done. So yeah, that's definitely true.
Yeah. So let's talk a little bit about using Python like that a little bit. You mentioned them before, like what's a recipe and where did they lie within Snowfakery, Cumulus, and like the YAML configuration files?
Yeah. So a recipe is itself a YAML configuration file, different than the Cumulus CI.YAML, which is a kind of orchestrates the overall configuration of an org. So the recipes are YAML, and then the Snowfakery Python code kind of compiled into an internal optimized format and then evaluated, sort of like an interpreter written in an interpreter. So you've got two levels of interpretation going on.
Gotcha.
But still, it's modern computers are still fast enough that even with two levels of interpretation, you can generate a lot of information very, very quickly.
Nice. And to kind of put a wrap around the role of the open source community, because you mentioned this started with an open source sprint. You've mentioned that people are using pull requests and things like that to, increase the number of things that can be faked and the recipes themselves. Like just kind of like give me the summary statement of like how involved the community is in producing a project like this.
Yeah, well, I mean, it definitely varies from individual to individual. I'd say that there's not too many people doing check-ins yet, at least to the main Snowfakery code base. More often, when it comes to the main Python code base, they are contributing either requirements, like through ideas, and I do brainstorm ideas with the community regularly, and in Slack and Power OS Hub and Trailblazer community. And then also they might be able to do a bug fix.
Gotcha.
Implementing a brand new feature. We haven't really onboarded a lot of people to that level.
Okay.
And then the other thing that they can, of course, contribute are documentation and recipes themselves. So that's actually, because I'm not an expert in every domain, of course. I know little bits about education domain, but I don't have internalized the whole education data architecture. So they're experts in that focus on the recipes that relate to that. And then when someone else comes along and they are brand new to Snowfakery, they don't have to imagine from a blank slate. They say, oh, I've got 90% of what I need in this EDA recipe. I'll just add my custom objects to it.
Gotcha.
Or even include it, as we described before.
Got it. Nice. And okay, so this is all online, documentation's online. I think your roadmap's online too, right?
Yeah. A lot of it's expressed in GitHub issues. Yeah.
Got it. So what are some of the other highlights that are coming out with 2.0?
Yeah. So as I mentioned, multi-processor, that's one of the two big ones. And the other big one is the ability to, so with Snowfakery 1, the model was that an org is like a blank slate, because it was designed primarily for performance testing, and you just delete all the data, repopulate it, and run your tests. But with Snowfakery 2.0, it can be more, it can actually pull in information, especially IDs, from the org and connect information in your recipe to information that already exists in the org. So it doesn't have to be a blank slate anymore, which is very powerful when you have pipelines of tools. Different other tools are loading data that maybe that you've written by hand, or basically data that comes from somewhere else. And salespeople are increasingly interested in Snowfakery, or sales engineers, of course, are getting increasingly interested in Snowfakery because of this capacity to, well, I've already got this data that I hand created 3 years ago or whatever, but now I want to scale it up to show a dashboard, or to show some visualization at scale. And so Snowfakery can be used in that context as well. So, and that's also where a lot of the really sophisticated, fake data accuracy type stuff comes in handy to make it. The sales engineers are the most picky about, it doesn't make sense that if the stage is in this field, then the date needs to be this, and if 3 objects down, that would need to be in this state if that's in that state, and so forth. So they push the boundaries of the conditional logic and the coordination.
And that's our show. Now, we will have links in the show notes, of course, to the Snowfakery project up on GitHub, as well as some articles that Paul has written on the subject. Now, before we go, I did ask after Paul's favorite non-technical hobby.
Well, I live in the beautiful Vancouver, so we like to get outside and camping. We actually camped across Canada. I mentioned that I took a sabbatical at one point, and we camped across Canada, so that was awesome.
I want to thank Paul for the great conversation and information. And as always, I want to thank you for listening. Now, if you want to learn more about this show, head on over to developer.salesforce.com/podcast, where you can hear old episodes, see those show notes, and have links to your favorite podcast service. Thanks again, everybody. I'll talk to you next week.